Hi, welcome to my podcast. My name is Isabelle Molander, and today for Genius Hour, I'm going to be talking about life on other planets. Are we alone? A question that pretty much everyone asks at some point, and the truth is, scientists really have no idea. There's no evidence to either support or deny the fact that there was life on other planets. Because one, we have no way of accessing planets that seem like they have the possibility of harboring life, and two, there are so many planets in the galaxy, it is difficult and time-consuming to investigate so many different ones. But with the multitude of planets, it seems improbable that there's not any others that harbor life. In a quote from Neil deGrasse Tyson, humanity deciding that there's no life on other planets right now would be like taking a cup of ocean water and saying there aren't any whales in the ocean. So how do we look for life on other planets? Well, what astronomers look for is that planets are in what's called the circumstellar habitable zone of stars, or just the habitable zone for short. This is the area of a star where water can exist in liquid form, which is what life as we know it requires to thrive. And we've actually found many planets that are in the habitable zones of stars. What are the requirements for a planet to be deemed habitable? Well, first is the temperature of the planet. Life generally exists between -15 and 115 degrees Celsius. If the temperature is too cold, liquid water will not exist and the chemical reactions required for life are much slower. If it's too hot, genetic material begins to break apart and water will quickly evaporate. Another ingredient for a planet to be able to have life is its atmosphere. An atmosphere holds gases inside of the planet, protects it from meteorites and radiation. Without a substantial atmosphere, gases like carbon and oxygen, which are necessary for life, will escape. Although more is not always better in this regard. Too thick of an atmosphere will hold greenhouse gases, which heat the planet, or just result in a planet entirely made of gas, like Jupiter, Saturn, Uranus, and Neptune. Really, what all the ingredients for life on a planet have in common is the fact that too little is just as dangerous as too much. It needs to be just right, which is why the habitable zone is often called the Goldilocks zone. Also keep in mind, all our assumptions about life on other planets are based on the fact that these planets will harbor life as we know it, meaning it needs relatively the same conditions as organisms on Earth to survive, and are composed of primarily the same stuff, carbon. Although it is important to note that with the discovery of liquid water on Europa, one of Jupiter's moons, in 2011, the idea of a circumstellar habitable zone being the criteria for sustainability of life has been altered slightly. It has been realized that liquid water can exist on many different kinds of planets or even moons. This idea needs to be looked at in conjunction with other factors, but habitable zone is a good base point for evaluating planets. NASA has said that there could be as many as 40 billion habitable planets that are similar in size to Earth. So what are some of the most promising planets that could harbor life? Well, that really is the difficult question due to the difficulty in finding specific information on these planets and the fact that there's 40 billion of them. What I believe to be the two most promising planets that are known so far are Kepler 452b and Kepler 186f. Kepler 452b, discovered in July of 2015, is very special because it is orbiting a G-class star, which is the same kind of star as the Sun. It orbits the star in 385 days and is 1,400 light years away. Where it really differs from Earth is the fact that it is 6 billion years old, 20% brighter, and has about 5 times as much mass as the Earth. Kepler 186f is less than 10% smaller than the Earth. It has a 130-day orbit around a Class M star, which is smaller and not as bright as the Sun. It receives 1/3 the energy the Earth does from its respective star. The problem with it orbiting a Class M or red dwarf star is that it needs to be much closer to these dim stars in order for it to be habitable. This indicates that it is probably tidally locked, which means it does not spin on an axis, causing each side to be left in extremes of temperature. These two planets are some of the most similar to Earth out of the known habitable planets, yet they are still not perfect Earth twins. So is there any possibility of exploring these planets anytime in the future? The answer, unfortunately, is no, unless there's a massive leap forward in technology. In August and September of 1977, Voyager 2 and 1 were launched respectively. They've been traveling for 39 years at 15,600 meters per second. Voyager 1, being the farther of the two, is 18.8 billion kilometers from the Earth. This number sounds impressive, and it is, but in terms of exploring possible habitable planets, it falls short. The closest habitable planet is orbiting a Class M star, Wolf 1061, which is 14 light years away. To put this in perspective, those 18.8 billion kilometers that Voyager 1 has been traveling only amounts to 18 light hours. So unfortunately, we must stick to observing these planets from afar. Also unfortunately, this form of observation is one of the problems with trying to find habitable planets. To find these planets, astronomers measure the brightness of stars. When planets pass in front of them, the brightness will dim very slightly. This form of discovery is a problem because it is hard to use with smaller planets, which could still harbor life. Although there are many challenges between us and encountering life on other planets, it does not mean that we should give up. Don't forget that NASA says there are 40 billion possible habitable planets. Just because we don't know about life on them yet does not mean it doesn't exist.